Hello, pals. In this very lesson, we're going to be solving the first question we were given as a take home in our previous lesson on division and multiplicative inverse of modular arithmetic. In our previous lesson, we perfected everything, about basic operations of modular arithmetic, and we're given a couple of questions to test us. So this very question was the first question we're given. So if you're seeing this very question for the first time and you want to give it a try, you can pause this very video and make an attempt. So we asked to solve 12 divided by 8 to be written in modulo 6. Now, this very question is very easy. I'm very sure that most of us got this very question right. So how do we solve this? We can use two major methods to solve this. First of all, we could use the multiplicative inverse method, and and also we could use the direct approach. So let's see what's going to be. Now, 12 divided by 8. Whenever we divide 12 by 8, we're going to get something, and that could be x modulo 6. We're using the direct approach this time around. But don't forget 12 divided by 8 also could be reduced. We could simplify it. So we could just simplify this to 4 here, 3, then 4 here, 2. So that's 3 divided by 2 equals to x in modulo 6. As simple as that. So quickly, we can cross multiply. 2 times s will give us 2x equals to 3 in modulo 6. So 2x got to 3 in modulo 6. So don't forget, we're going to get the multiples of 6. So we're going to do that very quickly. So 6 times 0 is 0. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24, and so on and so forth. So quickly, we're going to start with 0. 6 times 0 is 0. 0 plus 3 will give us 3. So that's 2x equals to 3 divided by 2. So it means s is 3 over 2 or 1.5. So it means when 12 is being divided by 8 in modulo 6, 3 over 2 is one of the results, one of the likely results among all the set of results. Don't forget, whatever result you're going to get must not be off to the base, must not be off to the modulo. I beg your pardon. Must not be off to the modulo 6 you're talking about. So 3 over 2 is one of them. So let's try out the next one, which is 6. So 6 plus 3 is 9. So that's going to be 2x equals to 9 with the variable side by 2. X also is 9 over 2 or 4.5, whichever way we want to do that. So the next is 12. 12 plus 3 will give us word, will give us 15. So that's 2x equals to 15. The variable side by 2. X is 7.5. So if S is 7.5, no, S cannot be 7.5. It doesn't make any sense because it's way more than the modulo 6 we are talking about. So what are we going to go with? We can go with 1.5 or we go with 4.5. Either of them is the result for X. So 12 over 8, which is 3 over 2 in modulo 6, we're surely going to get what? 4.5 or 4.5. That is the result. So whenever 12 is being divided by 8 modulo 6, our result is 4.5 in modulo 6, as simple as ABC. That's a perfect result, 4.5. So quickly, we can use another approach which we call the reciprocal method. So quickly, we can use another approach which we call the multiplicative inverse method. So for those that have not seen a couple of previous lessons, they will not understand this method. So we could easily get the multiplicative inverse. Don't forget that 12 divided by 8, is being reduced to 3 over 2. So you're going to get, don't forget this, becomes 3 divided by 2 in modulo 6. So we're going to look for what we're going to multiply with 3. We're going to use the multiplicative inverse of 2, I beg your pardon, to multiply 3. So this is 3 times 1 over 2 in modulo 6. So don't forget that 1 over 2 is a multiplicative inverse of 2. So the first thing we're going to get is we're going to get the multiplicative inverse of 2 in modulo 6. So let's see what that looks like. So what I'm going to multiply with 2 to give us 1. So whatever I'm going to multiply with 2 to give us 1 is going to look very much like this. 1 over 2 is going to play a role very similar to this. So let's say 2 times p, 2p equals to 1. We give us modulo word. That's modulo 6. So don't forget we have our table here already, multiples of 6. So first we have 0. 0 plus 1 is 1. So that's 2p equals to 1. So p could be 1 over 2 or 0.5. So the multiplicative inverse of 2 in modulo 6 could be 1 over 2, which is very basic. So the next, don't forget this p could be 1 over 2. Correct. So 6, it could also be 6. 6 plus 1 is 7. That's 2p. Equals to 7 divided both sides by 2. So p is 3.5 in modulo 6. So 3.5 could be the multiplicative inverse of 2 in modulo 6. Also, if you try out the 12 there, 12 plus 1 is 13. 2 divides 13. We give us 6.5, so we can't use that. So it can be off to the modulo we're talking about. So we are either going to go with this or go with 3.5. So it means it's going to be 3 times, what's the multiplicative inverse of 1 of 2, or what is playing the role of 1 over 2 here? Yes, 3.5. So 3 times 3.5 in modulo 6. So 3 times 3.5 will give us 10.5 in modulo 6. We're going to convert this to modulo 6. Let's check our table out. We have 0. We're looking for 10.5. We have 6, it's not the 10.5. We have 12. 12 is more than 10.5, so we're going to go with this. So it means 10.5 divided by 6 will surely give us 1. This 1 remainder, 4.5. So what's our result? Our result is 4.5 in modulo 6. As simple as that. So I'm very sure that most of us got this right. But it looks quite tricky because of the decimal. But that's just it. It's as simple as ABC. So if you've gained one or two things from this very lesson, I would love you to follow me on Facebook at Revelation Hub and subscribe to this very channel at EduMosaic. And also please share this lesson also with others. See you in the next lesson. Thanks and bye for now.